Good morning, everyone. I hope you had a great time till now. And today, I want to talk about some old fears that we usually have back in the days, and talk about some disaster recovery, sharing our story, what we did in Mollie, and so on. I'm Sina, joined to Mollie 2022. I heavily involved in the migration of the bare metal services into GCP, and after that, working on the reliability of the system core services and also network side of the Google Cloud. And we are trying to keep the SLA more than 99.95 for our merchants and customers. So today, I will give you some details about the history of the project, what we did, and what was the reasons. After that, I will give you some technical insights about the architecture that we use, and we try to implement it for the disaster recovery. And also about the execution time, what happened during the execution, what we did, what we followed during that time, and about the overview about the project, and finally about the resilience gains, what we gained from that project, and after that, the key takeaways. Before I start, I want to ask you some maybe simple question. Have you ever heard a question like, I have a server that is running for, I don't know, 10 years since Linux servers created Linux? Raise your hand. Have you ever heard? No? Okay, cool. And have you ever heard about something like, don't touch this server. Don't restart it. This is working. Don't touch it. Just leave it there. Okay, cool. And as this might be a best AI presentation, are you using AI in your production? Really? Okay, thank you. Thank you. Okay, let's go. Let's start from the disaster recovery strategy that we had in Mollie. History. As I joined as a site reliability engineer into Mollie, I involved into migration of the services from bare metals to GCP. Maybe it's kind of same for all the companies nowadays. The priority for that time was moving the services. Just that's it. It's good to have the secondary region up and running, but it's not a high priority. The best things for now is just moving the services to the Google Cloud, and that's it. But after some time, we saw some internal and external incidents. Some of them affected our merchants. It was not good. And some of them handled by our health check strategy that we have in the system. And also some other companies outage that we recognize them as an issue. Maybe we will have them later. So it was a big trigger for ourselves to review our risk, to review our process, to review our plan. Also, as we are a financial company, we must pass some of the checklists. For example, as you can see, based on the DORA assessment, our infrastructure should be reliable in case of any regional outage. It's not important for them what you are doing in your infrastructure, but the main point for them to pass and get the certificate and be certified for the regulatories is passing those checklists. So the good to have changed to must have. We have to have the secondary region up and running. So we set up the infrastructure in the secondary region. It took some time for us because the main point was that we wanted to migrate the services and we didn't have clear idea about the secondary region. But after that time, we decided to update our Terraform codes, Helm chart, deployment, and everything to set up the secondary region. And it finished in 2024 Q2. Let's talk more about the technical things now. I gave you some history, some reasons behind this decision, and now it's time for technical things. As I mentioned about the secondary region infra setup, we were ready for the next step to achieve multi-region availability. For this one, we started a project that we call it Mollie Platform Switchover 2024. We added another one for 2025. And same as many other simple projects, many other projects, we had planning and preparation and the executions. Let's talk about the preparations and what we did. I mentioned that the priority for the application, for the migration, was only migrating the application and services to the GCP. But the code was not multi-region aware. If I want to give you an example, let's imagine that you want to have a process, background process, run only and only one at a time. For example, we have a refund process in our processes. We don't want to refund 2 times to the people, to the customers. Definitely customers like it. Who doesn't like getting 200 instead of 100? But our merchant doesn't like it. So, as an example, the refund process must be running one at a time. So the code must be updated based on these kind of things to be region aware, and some of the specific processes running on a specific region. So it needed some updated and make sure that the application is working for those kind of things. And we set up the application into the secondary region. As I mentioned that we already have the infrastructure in the secondary region. We tested by some simple curl commands, port forwarding, some manual actions, and added some tests in our application pipelines and tested there and connect the application to the main region database. So it's time for the next step to test with the real traffic. For the real traffic, we wanted to have some amount of traffic in the secondary region, not full traffic because it's new and we recently updated the code. So we wanted to have some percentage of the traffic. If you are working on GCP, you might know about the classic global load balancer of the GCP. It doesn't support weighted load balancing. So back in the days, there wasn't any automation procedure for the migrating the classic load balancer to the new version, advanced version of the external global load balancer, and we did everything by ourselves. We created the load balancer, adding the IP addresses there, announced the IP address because some of our merchants needed to know this IP address. Update the DNS service and, for example, playing with the weighted load balancing of the DNS records, and migrate some of the data, some of the traffic to the other one to make sure that the load balancer is working. And after that, we wanted to make sure that the load balancer is working for the application. What we did there, we started by routing some low volume endpoints. We didn't route everything at the first moment. First, we started by routing some low volume endpoints. We make sure that it is working. We had some issue, we had some minor issue, we fixed them, and we saw that, okay, everything is working as expected. And then gradually increase the traffic by 1%, 2%, and so on till 5%. So we had something like this. 95% in the primary region and 5% of the traffic in the secondary region. So we understood that our code is working as expected. This is a good achievement for us. But still, we have another things for the regional outage. The database is still there, still in the primary region. After that, we ask our database team to set up the infrastructure for their database in the secondary region. We are not using any managed database services. Our database setup is kind of solid for ourselves. The runbooks, Ansible, and everything is ready, and the performance of the database is low for ourselves, and we don't want to use any managed services soon. So our database team set up the databases in the secondary region, added some replica nodes there. Also, during this time, the application needed some minor update for sending the read-only traffic, read-only queries to the replica nodes to make sure that they are working with the regional database. And we set up something like this. You can see that we had read from the secondary region, and we also have something in the primary region, but still the master database is in the primary region. We also test the master failover scenario in the staging, but not in the production. And the last part for this preparation was disaster recovery runbooks. We made our changes, but we needed to have a runbooks for the disaster, for the real disaster. And we saw the disaster from the scope of the disaster, from the scope of the outage. For example, it can be a zonal outage, it can be one node outage, it can be regional outage, full outage, partial outage. Maybe it's related to RabbitMQ. Maybe it's related to database. No, I think that one of the region is down. I want to full switch over to another region. So we wrote everything for all of these scenarios in our runbooks, in our disaster runbooks, and made sure that they are working on the staging. We test them multiple times. It took some time because it's a documentation, but it's needed for any kind of disaster. So the preparation part was about the application that I told you about. The application needed to be region aware. I talked about the migration of the load balancer from classic type to advanced version of the Google load balancer. I talked about the database and adding replica nodes in the secondary region, and talked about the disaster recovery runbooks. So we are kind of ready for the next step. And from this setup, that we had only one region, move to this setup. 95.5% of the traffic in the secondary region. Looks like it is working. Many of us in our company has the secondary region or other region, and we thought that they are working, same as here. We thought that everything is working, so let's go for the next step, switch over. The execution time for us had one main rule. Let's follow the real incident procedure. In our company, we have incident bot. It's written by ourselves. It's an internal tool. It has a good feature, drill feature. We can use it for testing environments or testing things. And it has it connected to the PagerDuty, and it can page other people if needed, create a meeting, Google Meet link, and these kind of things. So we follow the procedure and use the incident bot drill. And also we wanted to have postmortem. This is very good for the big kind of switchover or this kind of disaster recovery, because we wanted to see this procedure as a real incident, something like that. We planned for the time, September 26. So let's go. We have everything. Yes? First attempt, September 26th, failed. We had everything, but only one major code issue stopped us. We rolled out everything, but during the application failover, we saw some errors. We thought that everything is working. We updated the code, but no, we saw some errors. We thought that maybe it's related to some warm-up. It took time. We stopped the rollback. You can see that after first attempt, we rolled back the traffic and enabled the switchover for some specific services. But we saw the same errors there, and it was 6 a.m. We didn't want to do something, and we wanted to roll back everything and make the system happy for the merchants. And what was the issue? Old Moneymaker, our code base is something around 20 years old monorepo. And maybe you can imagine that maybe we missed something during our application code update. There was one issue in the client side of in the Redis client side, and that part didn't region aware. So when we switched the traffic, the old one was working and the new one was also working. So it was kind of a race condition for that time. Our application engineers fixed that one as well. And also we saw some other issues there. They fixed it as well. And update our test scenarios, update our code test, update our pipeline test, and all of these things tested on staging, test, and we prepared for the next attempt. We thought that everything is working. We can go for the next attempt. Keep in mind that sometimes for the planned procedure, it's better to warm up your system before your real execution. As an example, you might have autoscaler in your system. As it was a planned procedure for us, we increase our mean replica. This is a super simple one. Increase the mean replica to make sure that it is working because we wanted to move 95% of the traffic to the secondary region. It's a huge amount of traffic. So we pre-warm them and make sure that everything is okay there and minimize the rollout time. So prepare for the next attempt, and yes, October 9th. Again, but this time is different. Yes. This time was really different. I woke up an hour before the scheduled time, and I had this feeling that this time is the last time, and we can deploy and roll out the traffic. And you can see that we followed all the disaster recovery runbooks step by step, and finally we switch over the traffic without any issue. This was the big achievement for the company because it was the first time. Everyone thought that, okay, we have the secondary region, we are reliable for any kind of outage, but you saw that. The first time we attempted, but failed, but for the second time, we succeed. So if something happened, we know what to do. And you can see the face of us. We were super excited at that time. And let me give you an overview about the project again. We talked about the preparation, application code, load balancer, database, disaster recovery runbooks that took a long time for us, and also about the execution time, the rule that we followed. We wanted to follow the real incident standard, and also the execution time. The first time failed. It was okay for us because we wanted to make sure that the system is ready for this kind of outage. And the second one succeed. And the resilience gains what we got. Availability. We minimize the impact on a regional outage. This is very important. Let's imagine that it's 3 a.m. You woke up and you want to do the scenario of the switchover. And if you saw these amount of errors about, for example, Redis, what you want to do? You will have an outage for one region. You have the outage there, and you don't know what to do. You cannot do anything at 3 a.m. You need to find some engineers to solve your problem. Maybe it can take 10 minutes. Maybe it can take a couple of hours. For us, it took, for example, 2-3 hours for our engineer to find and solve the Redis issue. But let's imagine that it's 3 a.m. You don't want it. No one wants it. And multi-region compatibility validation. We made sure that both regions, the old primary one in the Belgium was working, and the new primary one in the Netherlands is working as expected. So if something happened to the Netherlands, we can move to the old primary one. We can move to another one. And also about the disaster recovery, we know what are the options during the incidents. I talked about multiple scope of the incidents, outage. If there is an application issue, what to do? If there is a regional outage, what to do? Does it need to full failover to another region or not? For ourselves right now, the best scenario and easiest and fastest scenario is just switch the region. That's the easiest part for us. And we are prepared for next outage. If something happened to one of the regions, we know what to do. And the key takeaways for us was, right now we know the low traffic time. This is very important for your project rollout. You should know about the time. If you want to have a rollout for your infrastructure, you should make sure that which time is the best time and low impact in case of unexpected issue on your system. Then you can plan your time, plan your project to do that infra change at that time. If we want to have that procedure during the office hours, definitely we had some kind of outage for a couple of minutes or half an hour, and definitely we couldn't have the uptime for 99.95 for our mission. It's out of our SLA. Also, also see it as a business as usual. Okay, we knew that there is a secondary region, but we didn't know that there was an issue there. So please, if you are SRE, do this or push your company to do this exercise regularly. This is super important. It can be, maybe you are working in a database team and you have replica. Please make sure that the replica server can be a master server sometime. Don't think that, okay, we have it there. It can be. In the reality, no. It won't happen. You might see many errors there, and you don't want it. And definitely, you will blame. And you should know the failure domains. For example, during the previous talks, we talked about, for example, different type of observability. Check your observability and see if something wrong. Let me give you a super simple example. If something wrong with the database, what are the impact on the page, on the dashboard page? If there's something with the RabbitMQ, what are the impact on the dashboards? And after that, you should know the rollback plan for yourself. What does it mean? For example, during our rollout, during our switchover, if we didn't know the rollout plan, it was not good. Okay, we changed something, and if we didn't have any rollout plan in the disaster recovery page, we didn't know what to do. Let's imagine that it's 3 a.m. You woke up, switchover failed, and you don't know what to do. Just revert the merge request. Maybe it's a simple merge request, but sometimes no. For our case, it was not a simple merge request. It was, for example, some change in the load balancer. It was some change in the database side. It was some change in the application side, something in the Kubernetes side. We can automate some of them, but some of them are still manually, and we want to keep them manually to keep the safeguard. So it's better for you to know the rollback plan and put it inside your disaster recovery. If something wrong, okay, let's accept the outage of the one region or this part for a couple of hours. We know that after a couple of hours, the outage will fix somehow, and roll back the issue, roll back your change. And that's it. This was the scenario of the switchover in Mollie. Thank you.